For a long time, one celestial body has captured the imagination of humanity like no other: the Moon. And now, after more than half a century since the last human footprint graced its surface, NASA's Artemis program stands poised to reignite our exploration of Earth's closest neighbor. This ambitious endeavor, named after the Greek goddess of the moon, is not just about planting flags and footprints. It represents a bold leap forward in our quest to unlock the secrets of the cosmos. Join us as we delve into the depths of NASA's Artemis program, unraveling the mysteries and exploring the limitless possibilities that lie beyond the lunar horizon. The context: NASA's Artemis program represents a monumental leap forward in humanity's quest to explore beyond Earth. Far more than a mere repeat of past lunar missions, Artemis is a multifaceted endeavor aimed at establishing a sustainable human presence on the moon, while also serving as a springboard for future missions to Mars and beyond. The program's inaugural mission, Artemis 1, lifted off from Launch Complex 39B at NASA's Kennedy Space Center in Florida on November 16, 2022. This historic launch marked the beginning of a 25.5-day lunar mission, during which crucial tests and evaluations were conducted to pave the way for crewed missions. Artemis 1 concluded with a successful splashdown off the coast of Mexico's Baja Peninsula on December 11, 2022, demonstrating NASA's capabilities in deep space exploration. Named after Artemis, the Greek goddess of the moon and twin sister to Apollo, whose namesake program first brought humans to the lunar surface on July 20, 1969, the Artemis program carries on the legacy of exploration and discovery. But Artemis is not merely a rehash of past achievements. It's a reimagining of human space exploration, with a focus on sustainability, international collaboration, and inclusivity. The genesis of the Artemis program can be tracked back to President Trump's Space Policy Directive 1, which tasked NASA with returning humans to the moon and laying the groundwork for future missions to Mars. Vice President Mike Pence further fueled this ambition by setting an ambitious deadline to land humans at the lunar South Pole by 2024. This accelerated timeline has propelled NASA into action, spurring innovation and collaboration across the agency and its partners. Perhaps the most ambitious aspect of the Artemis program is its role as a stepping stone for missions to Mars. As three-time NASA astronaut Stephen Swanson explains, the real goal is Mars. By using the moon as a testbed, NASA aims to gather the knowledge and tools necessary to navigate the complexities of a Mars mission. From understanding long-duration spaceflight to developing technologies for resource utilization, the moon holds valuable lessons for future exploration of the Red Planet. In addition to its scientific and technical objectives, Artemis embodies the spirit of inclusivity and diversity. NASA Administrator Jim Bridenstine has emphasized the program's commitment to landing the first woman on the moon, inspiring future generations of explorers to pursue careers in science, technology, engineering, and mathematics. Between 1969 and 1972, 6 Apollo missions landed a total of 12 men on the surface of the moon. At the time, the selection of astronauts was based on rigorous criteria, and there were no women at NASA who met the necessary qualifications. The prevailing perception of space exploration as a male-dominated field persisted until 1978, when NASA selected its first female astronauts. Since then, 75 women have ventured into space, making a significant shift in the demographics of space exploration. The upcoming Artemis moon landing serves as a poignant reminder of the evolving landscape in space exploration and the increasing inclusivity within the industry. In December 2020, NASA unveiled the Artemis team, comprising 9 women and 9 men, all of whom possess impressive credentials and expertise in space exploration. Chief Astronaut Reed Wiseman confirmed in August 2022 that all active NASA astronauts are eligible for Artemis missions, with final crew selections pending. At the heart of the Artemis program lies the Space Launch System, SLS, and the Orion spacecraft. The SLS, standing at an impressive 322 feet tall, is a powerful rocket designed to launch payloads into space. Paired with the Orion spacecraft, which can accommodate 4 astronauts, the SLS will facilitate crewed missions to the moon and beyond. The Artemis missions are structured into 3 parts. Artemis 2, scheduled for 2024, will carry the first 4 Artemis astronauts on a trajectory farther from Earth than any humans have traveled before. This approximately 10-day mission will include a lunar flyby, allowing the crew to evaluate the spacecraft systems while in deep space. Artemis 3, slated for 2025, will mark a historic moment as the next man and the first woman set foot on the lunar surface. Assuming the success of the previous missions, the astronauts will utilize a lunar lander to descend to the Moon's south polar region, where they will conduct scientific research and exploration activities for approximately a week. The Artemis project encompasses several key components aimed at establishing a sustained human presence on the Moon and advancing scientific exploration in space. At the forefront is the Lunar Orbital Platform, Gateway, a space station orbiting the Moon. This gateway serves as a vital outpost for conducting scientific experiments, facilitating lunar surface exploration, and extending humanity's reach into space. Crews of 4 astronauts will access the gateway using the Orion Deep Space Capsule, ferried into lunar orbit by NASA's Powerful Space Launch Systems rocket. These missions will enable astronauts to stay on the gateway for extended periods, ranging from 30 to 90 days, conducting research and preparing for lunar surface expeditions. Part of the Artemis initiative involves leveraging the capabilities of private aerospace firms to develop essential hardware and stimulate the growth of a lunar economy. NASA has allocated funding to various companies, including SpaceX and Blue Origin, to develop lunar landers capable of transporting astronauts to the Moon's surface. SpaceX, with its Starship vehicle, has been selected to provide the crew lander for the Artemis 3, making a significant milestone in commercial space exploration. Additionally, NASA has contracted smaller businesses to deliver robotic spacecraft to the Moon, tasked with collecting data and conducting research. Some of these companies are exploring the potential for lunar resource utilization, particularly water mining, which can be converted into rocket fuel. This endeavor highlights the growing interest in sustainable space exploration and the utilization of extraterrestrial resources to support future missions. Another critical aspect of the Artemis project is the development of advanced spacesuits tailored for lunar exploration. NASA has unveiled the Artemis generation spacesuits, designed to enhance mobility and comfort for astronauts during extravehicular activities on the lunar surface. These suits feature improved shoulder and leg mobility, allowing astronauts to maneuver more effectively in the lunar environment. With these state-of-the-art spacesuits, astronauts will be better equipped to undertake the challenges of lunar exploration and pave the way for future missions to Mars and beyond. The liftoff of a spacecraft marks the beginning of an incredible journey into the cosmos, and the launch rocket plays a pivotal role in propelling the capsule and crew into space. NASA's Space Launch System is the agency's latest innovation in rocket technology, specifically designed for human space travel beyond Earth's orbit. Unlike missions to the International Space Station, which require comparatively shorter distances, Artemis missions demand the capability to traverse much greater distances, nearly 1,000 times farther. To achieve this, the SLS is engineered to achieve speeds of up to 25,000 miles per hour, ensuring the safe and efficient transit of astronauts to their lunar destination. Approximately 8 minutes after liftoff, a critical moment occurs as the core stage of the SLS rocket separates, marking the transition to the next phase of the journey. As the astronauts continue their voyage to the Moon, they rely on the spacecraft's advanced systems and expertise of mission control to navigate the vast expanse of space and reach their destination safely. But where exactly is Artemis headed? For the initial Moon missions, the selected astronauts are likely to land near the Moon's south pole, a region of great interest and potential significance. This area is believed to harbor vast deposits of water ice, a precious resource that could sustain human exploration efforts beyond Earth's orbit. Water extracted from these deposits could serve multiple purposes, including hydration for astronauts, fuel for rockets, and coolant for equipment, unlocking new possibilities for extended space missions. Among the key destinations within the lunar South Pole region is the Shackleton Crater, a vast depression spanning 12 miles in diameter. This crater's unique topography creates permanently shadowed areas where temperatures plummet to some of the coldest in the solar system. These frigid conditions make Shackleton Crater an ideal location for the accumulation of water ice, a valuable resource that holds promise for future space exploration endeavors. As with any ambitious undertaking, the question of cost looms large. Estimates for the Artemis program's budget are still being refined, but the projections indicate a substantial investment. In comparison to the Apollo program, which cost approximately $23.6 billion in 1973, equivalent to over $136 billion today, the Artemis program is expected to incur expenses of $93 billion by 2025. Each launch of the SLS Orion system is estimated to cost $4.1 billion, reflecting the complexity and scale of the missions ahead. Despite the challenges and uncertainties, the Artemis program represents a bold and transformative step forward in humanity's quest for exploration and discovery. By harnessing the power of innovative technology, international collaboration, and scientific ingenuity, Artemis promises to expand our understanding of the cosmos and inspire future generations to reach for the stars.